Good morning. So welcome back. Coming to combinational circuits using VHDL. In previous class we have seen what is meant by decoder, how to write VHDL program for the decoder, that too in data flow styles we have seen. Now coming to another combinational circuit is encoder. So as per the functionality of encoder, it is quite opposite to the decoder. That is, it is also converts one coded form into the another coded form like decoder. But here usually the encoders are used as a priority encoders. Priority encoder, that is, out of different inputs, to which input it has to give the first importance. Okay, that is, generally the encoder is represented as 2 power n by n. Means it has 2 power n number of inputs and n outputs. So as I said, the action is quite opposite to the decoder means, so that this is a truth table representing 2 power 2 to 2 power 2 by 2 encoder. Okay, so that is quite opposite to the decoder. In previous class we have seen the truth table of the decoder with 2 by 2 power 2, that is with that one the opposite action we can observe. So there the outputs are, one of the output is equal to logic 1, whereas others are the zeros for every input combination. With reference to that, the opposite action if you consider here. Now the inputs are x0, x1, x2, x3 are 4 inputs and 2 outputs y0, y1. Here with reference to first one, x0 is the logical, it is in active mode. x0 is inactive, whereas other inputs are in inactive. So which of the input is in active, that it represents. So output is 0, 0. So x0 input is active. Okay, it means is x0 input is active. Then here if you observe, in second combination only x1 is inactive, so the output is 0, 1. In third combination case, x2 is inactive, therefore output is 1, 0. In the fourth combination case, x3 is active, that's why the output is 1, 1. So by seeing this, which input is active and to which the priority has to give, that you can understand. Let us see another truth table action here. Okay, now here if you observe this truth table, if none of the input is active, no output we are getting, okay. Suppose if x0 is inactive, automatically the expected output is zeros. Okay. Suppose if x1 is inactive, whatever the x0, if x1 is inactive, that is from x3 it will check. Okay. So which higher position is inactive, that for that one it gives the priority. Okay. So if you observe here, x3 is 0, x2 is 0, x1 is 1. When the x1 is identified, then it didn't check, it doesn't check what is the x0 value, automatically it shows 0, 1. Similarly, if x2 is 1, it shows 1, 0. If x3 is 1, it shows 1, 1. Okay. So like that it gives the priority. From the maybe MSB bit position case, it will check. Okay, if MSB bit is inactive, it shows that position value, otherwise it goes to the next level of checking. Like that it will it is treated as a encoder. Okay, priority encoder. Now based on this, what are the equations for y0 and y1 are? For y0 we have two places logic 1, therefore with reference to logic 1 the expected equations are the expected equations. So y0 having two terms, with reference to this one is one term and this reference to this term is 1. So with reference to first one it is x2, with reference to second one it is x3. Therefore y0 equal to x2 plus 3. That is the equation we can consider for y0. Similarly for y1, for y1 the equation is x1 plus x1, this is x1 plus, and this one is, for this one it is x3. Okay, x3, here we are getting x3, whereas here we can get the value as x1 x2 bar. What for x2 bar? I think no need x2 bar. x3 x1 is enough maybe. Okay, similarly here V output is there. The V output represents, if the value is 0, none of the input is inactive. Okay, if it is 1, one of the, at least one input is high. At least one input is high. Therefore, x0, x1, x2, x3 is the equation for V. Whereas for y1 it is x1 plus x3 only, x1 plus x3, not this one. Okay, so based on that you can realize the equations y0, y1, v. Based on the Boolean equations we can realize those like this. So once realization is done, also once Boolean equation is available means you can easily write the VHDL program in the data flow style. Okay, here three types of outputs we have: y of 0, y of 1 and b. Okay, so first of all entity declaration. See here, entity declaration with the word entity. Port to encoder is port of x with 4 size. I mean x is created as an array that consisting 4 locations, whereas y is an also array consisting 2 locations, and v is another output. Okay, so whatever the Boolean equations are there, those are directly written here. But here also y x2 bar is considered. X2 bar means x2 bar what for? I think it is not necessary. Okay, of course I will check and give the clarity maybe in the next class. Okay, so like that the VHDL program will be developed here. So I think you are all following how to write the VHDL program for this encoder. Similarly, in the behavioral model also you can develop the program. Okay, using if statement. Using if statement you can write it. Okay. Okay, see here, using if statement, if x of 1 is 1, simply y equal to 1, no need to check other. If x of 2 equal to 1, y 2. If x of 3 equal to, like that you can write the program. But the higher bit positions, if x of 2 is 1 means x of 1 is not, I mean if this condition is failed, then only it goes to here. Okay, so like that you can write the program. Okay, using if also you can write using the behavioral in case of behavioral statement. Okay, then coming to multiplexers. What is multiplexer? Multiplexer is also a multi-selector switch. You know that the multiplexer acts as a multi-selector switch. Okay, so n by 1 is the size of the multiplexer. Generally 2 power n by 1. The multiplexer is expressed as 2 power n by 1, where 2 power n number of inputs it has and 1 output. In addition to 2 power n data inputs, n select inputs also there, n select inputs. And this is the example of the diagram for 4 by 1 multiplexer. 4 by 1 we can represent as 2 power 2 square by 1, 2 square by 1, therefore 2 select lines. So 4 inputs are x0, x1, x2, x3 and 2 select lines are s0, s1. So based on this select lines data, one of the input is connected to output. That is, if both s1 and s0 are 0 zeros, x0 is connected. If it is 0 1, x1 is connected. If it is 1 0, x2 is connected. If it is 1 1, x3 is connected. Okay, so this is the truth table we can prepare for the 4 by 1 multiplexer. From this, what is the equation for y means? The Boolean equation for y is x0 s1 bar and x0 and not of s1 bar, and that is it is just a product term, right? x0 x1 bar x0 bar plus x1 s1 bar s0 plus x2 s1 s0 bar plus x3 S1 S0. Okay, like that we can treat the Boolean equation in lower classes, that is in lower semesters, that is in DELD case. You know that you have known how to write the Boolean equation in the XOR case by knowing the truth table. So using that equation, here is the program in the data flow model. But in the earlier in unit 1 itself, we observed that how to write the program in the behavioral model case using the case statement, that also we observed. So for 8x1 multiplexer case, this is the program. For 8x1 case, the program is like this. First of all, entity declaration. See here, entity 8 to 1 multiplexer is 8 to 1 multiplexer means what? 8 inputs it has. Okay, so the input is declared in the form of vector with the size 8 locations. So x in standard logic vector 7 down to 0. Okay, so 8 to data input means 3 select lines it is required. So the select line is declared as S in standard logic vector 2 down to 0. That is, S is a select line input declared as an array consisting 3 locations, and Y just it is 1 bit value out standard logic. Okay. Then in the behavioral model means the preferable concurrent statement is process of X begin case based on the select data. Based on the selected line data, right? One of the input is connected to output. Therefore, we have to check the select value. Suppose if it is 0 0 0, okay, when select value is 0 0 0, what is expected? Y x of 0. Okay, if it is 1, y is x of 1. If it is 2, y equal to x of 2, like that. Up to another you have to write. Then end case, end process, end behavioral. Okay, like that, very easy program. The programming point is very easily you can develop either in data flow style and behavioral style. If you have the Boolean expressions data flow model is preferable. If it is truth table data, you can write the program in the behavioral style. Okay, so for any sized multiplexers you can design or you can write the program like this, but here I have shown only data flow styles and behavioral models. Okay. And coming to another one is parity generators and parity checkers. About these two techniques, about these circuits, maybe parity generator and parity checkers, we can discuss in the next class maybe. Okay, now I am going to stop.